So I want to introduce Bill, who's our partner in Vermont, and he's going to be giving us an update on the vegetation study that they'll be carrying out in Vermont, as well as introducing Jason, who has been on our calls before, but we're partnering with him at Vermont Eco Studies um, to do some work that they'll give us some more details about. So Bill, you have the your co-host, so you can share your screen, or Jason can share his screen, whoever's going to be presenting.
Okay, great. All right. Well, thanks everyone for coming. This is so I'll get into what we were up to last year and our plans for this year. This data is part of the work that I did with Kristen, Callie, and Luke. Callie's actually here on the call listening in. Kristen's here. And I've had a lot of help over the years, work in progress. So lots of students have helped over the years. Samantha is here. Getting a message that my connection is unstable. That's always a bad sign. I'm going to stop my video. I've got a Vermont internet connection here, so I apologize in advance. Samantha's here as well. Samantha has been working on lab work, Borrelia testing in the lab and things like that. And Cheryl's here as well from UVM, Cheryl Sullivan. So we've got a Vermont contingency here. Let's see. So talk about there are really two parts: the vegetation management and then itch. I'll try to be brief. I'd like to leave some time for discussion between each section, because I think we're going to want to coordinate both of the vegetation as well as itch are being coordinated across states. So hopefully I won't be talking too long. And then Jason will talk about what he's up to in on the eastern part of Vermont and how we're going to collaborate. So just some brief background. We're in Vermont, and this map over here is showing you the number of Lyme disease, the per capita incidence of Lyme disease, and the highest rates are in the southern part of the state. We are in that. And if you look at the some of the CDC data over the past 15 or so years, the numbers above the bars are represent our rank. So for unfortunately, for many years, we're number one in a bad way, highest per capita rates of Lyme disease in the United States. Obviously, the reporting data isn't perfect, far from perfect, but it gives you a sense of the problem we have here. And then I'm just showing I have these several long-term study sites. Those red dots you see in the map, 6 of them are still active. There are 2 that I had to drop. And just to give you a sense of our numbers of ticks, this is a reference site in Poultney, Vermont. This one's just down the road from where I live, so it's easy for me to get there very frequently. And I have 11 years of data. This will be season number 12. And you can see just lots of fluctuation from year to year. It seems that every other year is a higher year. And no clear trend. It doesn't seem like things are going up or down as far as I can tell. This is about an average site. There are certainly sites that are tickier than this. And I should say that I selected my sites originally. These sites here that were selected, most of them were selected for a specific reason. I was looking at, I was interested in studying patch dynamics. And so I was looking for patches of certain sizes. So the sites where I have my long-term monitoring, I'd say they don't necessarily represent the tickiest sites in the area, but there is a range. But just to give you some context of to only sample in Vermont, for better or for worse. So we're right on the border with New York. This is New York right here. And I guess for NEWVEC that works out very well because this is a New England study, but I don't have New York data. So for the vegetation, these are our questions. Are invasive plant species associated with black lichen nymph density? Can we reduce tick densities by managing invasive plants? And which plant species should we target? And so the three that we're showing here are the ones that we're focusing on. We'll look for, we'll measure anything we can find, but barberry and honeysuckle and buckthorn are the most commonly encountered. And we know, of course, there's a lot of information about, well, there's some information about the role of barberry and honeysuckle. I think there's less on buckthorn. And this might be a study that many of you are familiar with, and in case you're not, it was one of several studies about the importance of Japanese barberry. And so when you have the number of infected ticks is higher than if there was a management intervention or no barberry to begin with. At one of my long-term study sites, this is a site that is on the high end, the very high end of the numbers I was seeing. And it was a landowner who contacted me and asked me to work at his site. And so we have these very high numbers of, in 2017, 2019, over 100 nymphs per 400 square meters of sampling. After the 2019 season, he decided to take it upon himself to spray his woods with glyphosate. And so I didn't really have much of a say in this. We were hoping to one day do our own management, but that's, we can't, it's not up to us. So, and I've just kept monitoring ever since. And so the numbers have clearly dropped. This does not necessarily, obviously this is an N of 1. So there's only so much we can conclude about what the mechanism is and things like that. But ever since that intervention, there's been a big drop, and we can see. And by the way, the plant he was targeting was barberry. It was a site with more barberry than most sites that I have, and now there's less barberry, right? And so here we are. He's now down more to like a regular level of ticks at his site. I'm just gonna make sure. Am I still here? Can you guys still hear me? Okay.
Yeah, we can still hear you.
All right, good. I keep getting these. I'm not looking, and I get these connections unstable message. All right, good. So what we did in 2023, we started looking at the percent cover of invasive plant vegetation, and we used belt transects, which I'm illustrating here in the diagram. And so we have a 100-meter transect where I do drag cloth method for measuring ticks, and then we look for whatever plants we encounter along that belt. So Kristen there is holding a pole that's 2 meters, I think it's 2 meters wide, right? And so 1 meter across each side, and then just and then we can use the tape measure there to measure the distance that the plant covers, and then we can use that to estimate percent cover. So that was our approach for 2023. We might want to change things for this summer, but in other words, we were getting the vegetation data for the exact location where we were collecting ticks. We used my long-term sites for this because we have the most robust tick data for those sites. And then we used some new sites as well. And in the map over here, the blue are the sites that we used. You'll see 2 red dots, and those just represent long-term sites that I no longer visit. So those were not used, but the blue dots are long-term sites and new sites. So here's just our summary of invasive plant cover at these sites. The blue is commonly encountered plant across pretty much every site had it, and it's the densities are the percent cover, I should say, is you can see that at the most we had a 40%. Most are under 20%, and buckthorn was quite abundant at some of the sites. Barberry is very limited. In fact, the only site that really has it is this DM location, and DM is this site here, which was the tickiest site. Okay, so so just to give you some context for what that site is. And so we just did a correlation analysis just to see what this would look like, and each individual transect, and we versus honeysuckle cover and versus nymph density, and no correlation that we could find. The densities that we're seeing are, the highest we have is a 40%. So these are relatively low densities. Certainly, Kristen and I both did our graduate research in New Jersey, and so we are both more accustomed to far higher densities than this. And then here I just took the honeysuckle cover from the long-term study sites where I have the most robust tick density data, because in the earlier slide it's just 1 year of data, so I'm not sure how robust that is. And again, no correlation, so just a quick and dirty sort of analysis to see what things look like. But again, honeysuckle, we're in the 0 to 15% range, right? So I guess that's good, but we can track that over time. So for 2024, and this will be, I think, my last slide, and then we can just discuss, have a little discussion about this. During the itch, we identified a location highlighted in red, which is near Lake Bomoseen, and there is a 30-acre forest there that's owned by the town of Castleton, and the town is willing to let us. And we found a lot of barberry there. We haven't explored the entire forest, but there's plenty of barberry. We did not find many ticks, but we only sampled, I think, on 1 day, an invaded site, and we have the opportunity to go in there and continue to take measurements, and they'd be willing to let us do some kind of intervention. So we have an opportunity here in Middletown Springs. So there's lots of barberry in this site here, and there's also a lot of barberry in this town right here. So I live, just for context, I live in Poultney over here. Most of my sites are in this area, but this town has that very ticky location, and there's lots of barberry, and there are plenty of other properties with barberry. And the nice thing about Middletown Springs, the community is very open to. We know a lot of these individuals. They're just very interested in solving their tick problem, and there are a lot of properties in here that we can access and do some similar work where we figure out what's going on with vegetation, and then perhaps do an intervention. So there's just because of the way the community is set up, it's a very friendly place for doing research. So that's the vegetation part, and see if anyone and by the way, one last thing is that how we measure vegetation this year, we'll do more. I think we're gonna do more of a site level analysis rather than just on the transect. I think that's might be a better way to do this, and we have more people working with us this summer, so it should be possible. So I'll just open up for questions and discussion. I see Lars has a question.
Those are tricky places you're working on. That's some solid densities.
Okay,
I was just wondering
okay.
in terms of vegetation management and especially removal of invasive species. I was just wondering if you have some thoughts about the pros and cons of it. I mean, if you remove the invasive vegetation, hopefully you will reduce the tick abundance to some extent, but at the same time, are you opening it up so people have more access and are more likely to contact the ticks that are left? They have essentially more ground ground where they can contact the ticks? I was just wondering if.
Yeah, that's an interesting question. I hadn't thought of that. There, the sites, I mean, these sites, the densities that we're seeing so far, it's not like New Jersey or Connecticut where you can't walk through it. All of these sites so far are walkable. But to your other point, in these, if we were in a New Jersey type forest, yeah, I don't have a good answer to that. Kristen, do you have any thoughts on that? Or
well, yeah, that's a good question. So to back up a little bit, my thinking is that there's some kind of density cutoff, because we've seen in literature the association with particular, at least some species of invasive shrubs, and abundance of ticks. But what we'd like to do is see if there is a sort of figure out that mechanism in a less densely invaded area, sort of where we are in Vermont. As you go south in Vermont from where we are, it becomes there's more problematic areas when it comes to invasive shrubs. So most of these landowners are accessing their land all the time. And whether there's thorny things to walk through or not, they're letting their dogs run through, their dogs are picking up ticks, et cetera. These are large areas. It's residential, but it's not like southern New England residential. It's not very densely populated. And so you have large pieces of private land. And so, and they go up the mountainside. So there's some elevation as well here. So it's not like a town with walkable sidewalks and definitive yards and things like that. It's very much more natural landscape. So some of my thinking is to try to get more at looking at capturing more of the density measurements of both invasive shrubs, but also the native shrubs that are there, and looking at some humidity variables as well. Because I think if you're eliminating shrubs, you're also eliminating cover for hosts. So is it the type of plant that's there? Is it the cover that's there? Is it both? There's studies that say barberry has like that perfect humidity, but for ticks, but if we don't, in Vermont, if we don't have that threshold of density, will that matter at all for the ticks? So that's part of what we want to try to get at with better sampling design and more intensive sampling, and trying to find some variable sites. So
yeah, I think James, I guess, is next.
Hi. For those of you who don't know me, I'm also with CDC. Same team as Lars. I had Kristen, you kind of touched on this, but I had a question about the nature of the vegetation. We're talking about invasive species. I'm asking this having worked mostly in southern parts of the Northeast, like New Jersey and the Hudson Valley, where you can't find native understory because it's so heavily deer browsed. Do you have sites where you have kind of native understory still in that part of Vermont, or is it just so heavily deer browsed that you're just seeing these invasive species?
yeah, we definitely do. That's a huge plus. And I'm used to working in New Jersey, downstate New York, also Midwest, Chicago region. So I have seen those kinds of understories where the only thing native are the overstory trees, and a few little things, maybe a jack in the pulpit here and there that have been sheltered by an invasive shrub where deer can't get to them. And deer management is a huge sort of social political issue here, because hunters want to see enough deer to hunt, but forest ecologists want to keep the densities pretty managed so that we have regeneration of forests, since forestry is a big industry here as well, and same with Maine and New Hampshire. So it's a little bit of a tricky social issue too, which I find really interesting. And landowners, there are more and more landowners that are prohibiting hunting access to their private land for hunters. They're posting their land. And so that's become more frustrating for hunters as well, because there's fewer places for them to go. So there's this interesting sort of social piece, I think, that, is kind of another study, but having, I think we can find areas with some viburnums, some definitely blueberries. And last year with we just kind of took notes a little bit on where we saw along that belt transect that Bill showed, where I just made notes of where we saw, prominent areas of dense native vegetation as well. But a lot of these sites have been disturbed through sheep, the history of sheep browsing and cattle browsing here, and also quarries. There's a lot of old quarries and disturbed kind of agricultural areas, old homesteads, things like that. So, just like in other parts of New England, we have lots of stone walls and hidden little old foundations and wood piles. Some landowners like to keep their woods really neat looking, and certain areas, more cleaned up, and other landowners don't. So there's all those kinds of variables too. So a lot of interesting questions. But I think, yes, to answer your question, there should be plenty of areas to find native vegetation.
Thank you.
Lars, do you have another question, or is your hand still up from last time? So any other questions or thoughts?
Well, I had a question actually. I was wondering what your plans are in terms of the site-wide vegetation analysis for 2024. Do you have like a brief overview of just like what you're thinking for this year?
Yeah, so we have to go back to a select amount of sites. I don't know that we'll cover as much ground. That's sort of the trade-off with doing more intensive vegetation sampling. So we've generally done those. I believe, Bill, you've done those belt transects or those transects for ticks around the same areas every time you've sampled. So what we plan to do is set 4 to 5 plots per site to really measure some density of shrubs, but we also won't be doing this totally randomly because we want to make sure it's somewhat in proximity to where picks have been measured anyway. There's a lot of ravines and wet sites and, other areas to stay away from that would increase variability in a lot of ways. And we don't want to go too high in elevation either. So that's a huge task for the next, starting next week, basically, is figuring out where to set up some of those plots. And then just, right now I'm thinking 4 by 4 meters to capture the enough area to have enough different kinds of shrubs in them. We don't have a lot of the other things that probably many of you have in your sites, like Japanese silkgrass and garlic mustard and the smaller-ish kind of invasive plants. So I think we're going to focus on the shrubs that Bill mentioned. And then some of our buckthorn sites are actually really mature buckthorn. And so they're over 10 to 12 feet tall buckthorn. So I'm sort of thinking that's almost even a different kind of microhabitat because it's so dark underneath those, nothing else is growing, and it's higher than maybe a deer or a small mammal would pass through. So, so thinking about sort of questing behavior and all that kind of stuff too, I'm trying to figure out if anyone has suggestions. It's a trade-off between getting our team to be able to get to everywhere, plus, sampling as intensively as we'd like to try to capture, sort of pseudo microhabitat conditions that a tick might care about, right? Or the small hosts might care about too. But again, we don't have the deer densities either that folks south of here do. So, we don't have 100 deer per square mile like suburban New Jersey or Massachusetts does. So, so we do have areas with native plants, but there's definite sign of deer browse as well. And we've kind of looked around for deer scat signs and things like that, but that's kind of unreliable as well. So,
Yeah, have you thought about doing something like adding a trail cam or some way to survey the other populations in the area as well, like the biodiversity, have some sort of measure of the biodiversity on the site?
We have contemplated trail cams, at least for capturing deer. But part of it has to do with the landowner has to be okay with mostly what we're doing there and how we're using that information. And some of them have trail cams that they might be willing to set up too. So we kind of have to work that out a little bit. Just most of my research was done on public land for easy, it's sometimes easier. So working on private land with this many landowners to try to get as many people to be okay with all the kinds of things we want to do. I don't know if Bill might have mentioned too, some of our landowners are very anti-treatment of invasive plants altogether with any kind of chemicals. And some are open to that. So we're going to try to play around with that too, to see if when we get to the management sort of suggestion stage, to work with people where they are. Everybody's concerned about ticks and trying not to get diseases from ticks, but what they're willing to do to manage their landscape is kind of variable. So if we can put up some cameras, I'm not sure how much they'll capture all the little things like voles and mice and things like. And I've had some upset up on my campus this winter. Because we have natural lands on our campus, and the smallest thing it triggered it were rabbits, so we could get those, and squirrels. But the smaller stuff we might not get, so to think about that. But that's a good suggestion. Thanks.
Thank you.
Yes, we're going to kick it into high gear after our grades are due. We both are at the same institution. Our grades are due tonight, so. And I have actually 2 students on this call who are actually still waiting for their grades. So sorry about that. Anything else, or should we move on to the next part? Before you go, I wanted to just very briefly tell you what we did last year for itch. Now, itch was the is tick control helping, where we were looking at how different treatments of residential properties would affect tick numbers in Vermont. We just used this year to get baseline data. So we had no treated sites, and so I'll just quickly go through what we did and then take it over to explain what Jason's going to talk about. So just showing you here my long-term sites, and then the itch sites. So it was great. We expanded into a lot of different areas, and that alone was really nice for our vegetation work. So it was that was great. I just threw together some photos here. Hang on a sec. Sorry, I got to stop my screen. Just to give you a sense of the size of these properties. This first one on the upper left, the property was so large that the landowner showed us we had to take a 4-wheeler just to tour the site. Okay. And then huge fields with some forest. This one on the bottom right. These are all of these sites are in Poultney, the town I live in. I live in the more residential area, and these are outside of the village. And the point here is that it's really hard. And so for itch, this is not a reasonable place to do residential tick control with spraying, right? And we might think, okay, well, we don't have to worry about all these areas, just the area around the home. However, these landowners are using all of their property. They are farming or logging, cutting trees for heating. They are just doing all sorts of activities, haying. So people really are using their properties, and these are just massive properties. Again, I am from New Jersey, and you just don't have properties like this in New Jersey, right? So that was the challenge. But we did have some problems in Zone B. We found more ticks in Zone B then the zone A was that one right on the edge. Zone B was going in a little bit. Some of the infection data, we didn't have a huge amount. Well, I guess we had a reasonable, and the Borrelia numbers are very close to what I've been finding over the years. Notice there were 2 dermacenter. That's noteworthy because that's the first time I've seen this species in any of my study sites over the past 10 years. The dermacenter is very common on the eastern side of Vermont, but I don't think I've ever seen it on the western side until last year. So that was really interesting. And then we found a Miyamatoi in an Exodus larvae. I thought that was interesting. And that was okay. So and so then what I'm going to do, so for 2024, because of our challenge with our area is not a good fit for itch, and there are no PCOs anyway doing any kind of spraying that I'm aware of. But we were lucky to meet Jason Hill of the Vermont Center for Eco Studies, who coincidentally has a project that happens to be very closely aligned with itch, and so we thought we would try to team up and continue the itch work on the eastern side of the state. So Jason, I'll hand it over to you and let you share what you've been up to, and then maybe we can have a discussion about what everyone thinks of this.
Hey, thanks, Bill. It's great to meet everyone. Thank you for the opportunity to say hello to folks. Just as a background, I'm a quantitative ecologist, and my background is in ornithology and entomology. And the project that we have going right now with ticks here at the Vermont Center for Eco Studies, we're located across the state from Bill on the eastern side of the state, right next to Dartmouth College. This project that started out of a bunch of members in the community approaching us and asking, as an applied conservation organization, what are the evidence that spraying backyard ticks, chemical control in backyard settings is an effective way to control ticks, and if it is, what is that potentially doing to invertebrate populations? And that was 2 or 3 years ago, and that's how this project started. So it's a bit out of my wheelhouse, and I've been learning a lot. So I appreciate any questions and insight you're all able to give. But the basic gist is that here in the Upper Valley of Vermont, there's more than a dozen companies that chemically treat for ticks in residential and business settings, mostly on mowed lawns. And last year we started sampling residential properties, mostly some town parks that also spray and such. Sampling before the companies come to spray, typically 24 hours before they spray, and then 24 to 72 hours after they spray. Sometimes they spray on a Friday. We can't get there till Monday. They don't work the weekend, but so we also do that on control properties where they're similar properties, but of course they don't spray. So I think, sampled 74 properties last year. Half of them were properties that commercially sprayed for ticks, and half that served as controlled. And we have nowhere near the tick densities that Bill reported. Nothing like that. Like a thousandth of it. It's like our tick density here is in residential lawn settings is something like 0.002 ticks per square meter. Nothing like those nymph densities that Bill showed. So we survey ticks in lawns because that's where the companies here spray for control. None of the 12 companies that we know of actually venture outside of the matrix of the lawn and spray into the forest, for example. They walk the edges of the lawn and spray into the forest or whatever the matrix is outside of the mowed lawn, but they're confined to the residential lawns. So that's why we sample the lawns, admittedly understanding that the tick densities there are much lower. So we do the standard tick dragging across lawns. We do that in 2 different sections within the lawn. One of that is we call the interior of the lawn, which is more than 3 meters or more from any edge of the lawn or any internal flower plot, garden, thing like that, and which we would presume to be the safest spot for humans there. And then we survey on the edge of the lawn with the edge of the flag just half a meter from the edge of the mowed lawn, right along generally the forest ecotone that surrounds most of these Vermont properties. And then we sample by flagging, by dragging sometimes, but usually by flagging 1 meter off of the lawn, standing at the edge of the lawn, reaching into the forest and flagging. So that's how we assess tick densities. On each of these properties, we also assess invertebrate diversity and abundance using beat sheeting. Because we're in a race for time, you know, the companies are a bit unpredictable when they're going to spray, even if they have a scheduled date. Rain and staff personnel makes that less than 100% reliable. So we're often racing to a property to be there before the spraying company is, or the day before. We don't have an opportunity to set out traps for insects or other invertebrates overnight. So we use beat sheeting, and on each one of these properties, before and after, we use beat sheeting at shrubs. We separate, we identify shrubs to genus typically, and we beat sheet up to 30 different shrubs on their property and rapidly assess two very skilled people, rapidly assessing invertebrate diversity into the beat sheeting. So rapidly counting 3 spiders, 2 springtails, 5 thrips, 2 beetles, caterpillar, like that. You get really, really fast, really good. Of course, this is sampling, not censusing, so it's imperfect. So yeah, last year we sampled 70 some properties, 140 ticks in total. It's about 50-50 for us over here on the east of the greens for black-legged ticks and American dog ticks. Sampled 2,000 shrubs, and from that, over 9,000 invertebrates that we rapidly assessed from those beat sheeting efforts before and after they sprayed on the treatment properties and then on both visits to control. I should say when we sample a property, it's randomly divided in half. We sample half of the property on the first visit, and then we sample the other half of the property. That does introduce sampling variability by not sampling the same areas, but you know, there are pros and cons to doing that. Of course, we take the ticks away with us, so we are already lowering the tick density before they even spray on that section of the lawn that we surveyed the first time. So that's part of the reason we don't return. Beat sheeting does kill some insects as well. So to avoid the suggestion that it's the researchers that are potentially driving any pattern we see, we beat sheet new shrubs and trees within 2 meters of the ground, up to 1 meter off the edge of the lawn. So yeah, last year sampled 70 some properties. Let's start with tick. So the tick densities did appear to fall by more than 50%, 50, more than 50%. All the different companies spraying chemicals combined, and from the pre-visit to the post-visit. So the vast majority of ticks were found right along the edge of the lawn, of course, and right off the edge of the lawn. Although 14% of our ticks were more than 3 meters into the interior of the lawn, which is still a very small number. For the invertebrate assessment, again, we sampled 2,000 shrubs last year, 9,000 invertebrates that we counted. And no changes for any of the 20 broad taxonomic groups. Typically at the order level is what we identify things to. Spiders, beetles, diptera, etc. And on the control properties, there were no changes in any of the groups, first visit to second visit. But on the treatment properties, the majority of groups, 75% of the invertebrate groups that we were able to quantify, significantly declined. Average declining rate was something like 23% for those, for the 15 or whatever it was, 15 of the 20 invertebrate groups that declined. Average declining rate is like 23% or something. Some groups were a little more affected than others. I think like spiders, for example, 30% decline from the first visit to after they sprayed, and caterpillars 40% decline. And some groups like beetles and ants really showed no change in pattern at all from the first visit to the second visit after they sprayed. So yeah, that's the gist of it. We do separate out things by invasive plants. We separate We separately sample honeysuckle, barberry, and things like that. I didn't see really any difference there of effect of the treatment or association between the presence of those plants and tick densities. But those are pretty uncommon plants in these residential settings. Less than 10% of our transects on the edges of the lawns contain one of those invasive species. So they're not abundant to begin with. A lot of landowners here intentionally remove those plants from the edge of their lawn. So no association between tick density or insect declines and the presence of those non-native invasive plants, but recognizing they're a small percentage of the landscape component at the edge of the lawn to begin with. So yeah, so I think that's all I'd say about that. We have a second field season this summer. I have a larger crew, so we're hoping to sample another 100+ properties this year. We started in April, and the company starts spraying here in February, incredibly. They get a break in the snow. So yeah, Tom. All right. Oh, Tom, did you have a question?
He's muted though.
Oh, sorry.
Sorry. We got two different devices going on here.
I got 3 monitors. I can.
So I guess I'm sure you must have controls for your other invertebrate counts, but when you mentioned caterpillars, the thought popped into my mind that there's seasonal variation as well. So like how are you controlling for that? I guess it would be if you have treated and untreated properties, but I could imagine big shifts in what stages of insects or what kinds of insects might be there at any given time of the year.
Yeah, so I did say caterpillars, thank you. And all Lepidoptera are bundled in that. It's just rare for us to, we one adult butterfly that ended up in our sample. And so mostly we're talking caterpillars. So I did say caterpillars. So I don't anticipate any reason why toxicity towards these groups would vary with time, but I definitely assess that their different relative abundance of those groups changes seasonally. And last year, our sampling was in a two-month intensive period. And part of our impetus of starting earlier this year, not only to get more ticks into our sample by sampling earlier, but also there's very much a question to be asked there. If there are fewer insects out and about in April, and they dramatically are so compared certainly to July, then maybe the mortality rate is lower, or maybe the mortality rate is the same, but there are simply fewer the overall number of insects killed by the spraying is less, fewer individuals. I could also see the counter argument that in April when they spray, there are certainly insects out and available, but there's less leaf out on the trees. So there may be that there's less protection from the spray itself and there's fewer places to hide. And I could see an argument that kill rates could be higher early in the season before leaf out because there's greater probability of the chemical directly contacting the insect. So, last summer our sampling was mostly June, July. And this year we started at the end of April. And so I'm really hoping to combine these 2 years of data sets to be able to look at the seasonality of the effects. And I think you're right on there. The controls, each day we go out, we sample the treatment property. We're also sampling a control property that same day. Yes, Lars.
Thanks, Jason. I was just wondering, is the intent of the companies when they're spraying to spray only the lawn, or is their intent also to spray the ecotone to the woods?
They purposefully also, so majority of their time is spent spraying the lawn. What they tell customers is, this is where you spend time playing with your dog and your kids. And so that's why we spray there. They do all the companies I know of also purposefully spray the edge of the lawn Some of the companies use surfactants that makes it really visibly obvious, the line of the spraying. And if there's dense vegetation, and it's typically 2-meter height and below. And I've watched them many times. And homeowners videotape. We ask the homeowners to note where the companies spray, so then we can concentrate our sampling in just the areas that the companies actually spray. So some homeowners follow the guys around and film them with cameras. And yeah, they walk to the edge of the lawn and they spray about to this height usually, off of the lawn, right at the edge of the lawn.
So I was just wondering, could you, if
spray
they
up the trees too.
if they spray into the ecotone,
Yeah.
could you sample on the wooded side of the ecotone to try to get more ticks, or is it just too dense and hard to get in
So
there?
we do sample the 1 meter off the edge of the lawn.
Okay.
By flagging half meter and from the ground half meter up, we intensively flag that surrounding forest matrix typically. And that's where the insect sampling comes from as well. I've really, my background work is in grassland ecosystems, so I've definitely thought a lot about how to sample invertebrates in the lawn. But besides vacuum suctioning them up and then spending a lot of person power and money sorting through those in a laboratory, which I've done enough of for a life, I don't have a great way to rapidly assess lawn invertebrates. You might argue that that's where a higher rate of mortality is occurring because the chemicals do drift, obviously, but I don't have a great way to assess those invertebrate communities. I will say some of the companies spray gardens upon request. They will go into the garden and spray your tomato plants. And, we sampled a property last week. Homeowner, she is a hobbyist beekeeper, but she's, I don't know, 30, 40 hives. And she has them spray her hives. She thinks it may help with mite control for honeybees. So she has them spray them. Like the guys walk right up and literally spray the European colony, the colonies of beehives. So they will and a lot of these companies also spray the sides of their houses and the foundations as well. Not really sure what that's about, honestly, but yeah. Yes, Andrew.
Yeah, Jason, how much granularity do you get in terms of the actual products being used and then the formulation and the nozzle calibration and in terms of the nuts and the bolts of the spraying?
We have basic chemical makeup for every chemical. Many of the companies on their product sheets have 98% of the chemical volume identified, and then the 2% is proprietary something. Some will say like it's a blend of permethrin or something, but so yes, that's definitely a limitation, is the lack of precise information about the complete chemical makeup of what they're spraying. That information is often not available to the homeowner and not to us either. But some of the companies spray like Cedar Wondercide. Product they have the full label for, but some of the companies are less than forthcoming with sharing information. In terms of the crews themselves, I've talked to many of the crews. Typically think the crews are college students on summer break. Typically, they are. I say that they don't care so much. They are just that's a job, and I've talked to a lot of them. And I would speculate there's a lot of variability.
Yeah, that's one of the things we've been struggling with is that, even operator to operator at the same company or certainly between companies, the kind of the rigor and attention to detail and and there's no way to adjust for that. It's just more of a fundamental problem. Yeah.
I think it's important. So yeah, I mean, we could replicate this with a controlled effort. In a controlled setting with the same chemicals and the same nozzle, right? Same backpack pressure, everything. But this does measure something in a real world setting and encompasses that variability. If anything, it likely lowers the apparent effect it has on our vertebrate communities in a couple of ways. a number of property owners told us, well, when we say, where did they spray? They'll say something like, well, the guy with the beard loves to spend the time on the hill. The young kid, he's always focusing on the deck, but he never goes in the front yard if he's here by himself. So that means we're probably sampling some areas that are effectively controls on treatment properties sometimes as well. And so if there is a negative impact on the invertebrate communities, and our data suggests there is, then we're measuring that on places that were sprayed and then averaging that out with places that weren't sprayed. So the true mortality effect is probably being underestimated, be my guess. Also because we sample 2 or 3 days sometimes after they spray.
Yeah.
And I suspect mortality is pretty quick, within hours, minutes maybe, for the invertebrates that are sprayed. There's opportunity for new insects to fly in and take those place and to mask the apparent negative impact of those chemicals as well.
Mhm.
But I think all that would, I don't see a way that would make us overestimate mortality. I think it would just cause us to systematically underestimate it, unfortunately.
Yeah, and with a large enough sample size, it kind of comes out in the wash if there's a lot of variability.
I hope so. It is a nuisance, though. I agree.
Yeah. Okay, thanks.
Yes, Steve.
Yeah, hey, Jason. I'm sorry I had to step away at the beginning, so maybe you already answered this question, but I'm just curious about your recruitment strategy, because it sounds like some of the homeowners might be a little dubious about the companies they hired if they're following around with cameras. How did you get people into this study?
There is a lot. It's really fascinating psychology. There's a lot of mistrust.
Mm-hmm.
And it doesn't help some of the companies make some ridiculous claims on their websites, like our products do not kill pollinators. They only kill ticks. Okay. So on both sides, the people that don't spray that are involved in our study and the people that do spray. And a lot of the people that do spray, one of our first interactions is they typically tell me their whole medical history around ticks. I had anaplasmosis in 2019 and they often apologize to me for spraying. I guess because I'm an ecologist and they think they're having an effect, but they think the effect is worth having because they don't want to get a tick-borne illness. So it'd be mine. In terms of recruitment, we have a website. We have a listing of like 5,000 people here in Vermont that get our typical e-news every month. Been on Vermont Public Radio a couple times, and a lot of people signed up using my Google form following those. And we logistically are limiting ourselves to the upper valley of Vermont, just 2-county area basically, just so we can get more properties surveyed in a day and just spend less money on mileage, quite frankly.
Thank you.
Mm-hmm. Yes, Kristen.
Hi, Jason. I was just curious about, are you seeing a difference in your average decline depending on what the chemical is, or do you not have that much replication? Like, do you only have one company using one type of chemical and 5 companies using another? And in addition to that, if the answer is, well, depending on what the answer is, I guess, do you have participants who are curious about your results and would be interested in changing either who they're using or not, stopping spraying or anything like that?
So last year, our sample largely, not intentionally on my part, there's one company here locally, they're called Pure Solutions, and they have a really effective marketing campaign. And they have a really attractive logo. It looks very natural. And, they do a great job. The customers display their designs in the yard, they get a 10% discounts. So you see their sign everywhere. And they have a corner of the market here. And although we do have 12 different companies, they're probably like, last year they were more than 90% of our sample. I really tried hard. And when I was interviewed on public radio, I really stressed for people that use traditional synthetic insecticides, I really need you, more than the essential oil folks, because that was the original intent of the study, was to look at essential oil-based poisons versus synthetic poisons versus the control. And I don't think there are just a lot of people that use traditional synthetic poisons here. That probably says something about our community here. So I can't assess that. Yes, many homeowners ask me, hey, is that JP pest stuff better than this crap I'm getting from chippers? Because I don't like the smell of it. And we are completely neutral in our interactions with homeowners. We always say like, I don't know, you know, that's what this study is about. We're trying to find that information. We get asked a lot about the effectiveness of the chemicals, and we play ignorant to that. We are not trying to influence their behavior during the study. The intent, of course, is to empower landowners to make the decisions on their own. We don't want to change what they're doing during the study. Yeah. Well, thank you very much, everyone. And it's all new for me, and I'm learning a lot. And I should stress, you know, because we're sampling just a meter off of the lawn, I'm not trying to make the claim that, you know, these spraying results in an overall 20% net loss of invertebrates or something like that. You know, we're sampling a very thin strip. You can visually see the chemicals travel greater than a meter into the forest. Even in dense hedgerows like arborvitae, you can see the surfactant goes in probably 2 meters. But it would be interesting to see how the lethal effect drops off with some distance from the edge of the lawn. But I don't have those data just because we sample within 1 meter of the edge of the lawn, because we feel confident that area is sprayed. Yes. Tom. All right.
You mentioned Pure Solutions. Are they spraying IC3?
They spray, by volume, it's like 98% winterberry oil. I'd have to look at the sheet. I do have their sheet to see what else is in there. I don't remember off the top of my head. Is that something I should be heads up for, or?
Oh, I was just wondering because maybe there's lots of people called Pure Solutions, but we interacted with Pure Solutions. I think they were outside of Boston at someplace.
They are registered. The owner lives here locally. It's a guy named Kyle Jones, but they are registered in, I don't know if they're registered. I think he told me they're just registered in New Hampshire and in Vermont.
So maybe it's just somebody else using the same name. Do they spell it P-U-R or P-U-R-E?
P-U-R-E.
Oh, okay.
Huh.
Different.
And do you have sites in New Hampshire, or is it all Vermont?
Yes. Yes, we have a lot of sites, and there's definitely a relationship between affluence and probability of spraying, I would imagine. You know, many people spend more than $1,000 a summer having their property sprayed for ticks. And we sample across the river in the Dartmouth area and surrounding that, and that's where a lot of properties are sprayed. And as you get, yeah, so we sample both sides of the river.
It's really, you're probably what, like 70 miles from me due east. It's a totally different place.
Yeah,
it's great. I mean, I love it there, but it's just a totally different type of demographic.
Different economic reality over here. We're the second wealthiest zip code in Vermont, not me personally. Yeah.
Cool. Thanks, Jason. Thanks everyone for coming and listening. And I guess we have to get to work now. Do some field work.
Get some grades in.
Yeah.
All right, great. So I guess if there's no other questions, we'll conclude today's meeting.
Thanks, Jason.
Yes, thank you for the presentation.
Thanks, Nolan. See y'all.